Okay, so as we proceed forward, what you had learned this chapter dealt with the majority of that periodic table and organic compounds here towards the end. So we have some elements up there and some compounds. This is just a general review of what you would see on your final. Questions for part one come from the organic compounds section, and part two, the problem solving, goes back from January all the way through May 10th that we just finished with last week. So when it comes to what you see on the left hand side, those are just your individual elements, and I want to remember what we did with those elements last January and parts of February. Bohr model is one, and a configuration is the other. Okay? So, does anyone remember what the difference is? It's more important to know how to use that slide rule and is to, let's say, memorize it. Okay? We didn't quite do the dot diagrams yet. That was in a little later. Okay, so go ahead and pick any one of those elements, or would you rather work from the top down? Top down, okay? So let's go ahead and do the Bohr model. So why would that number go in that circle, the nucleus? That's the atomic number, and it also identifies what? Number of protons. And if it's neutral, have the same number of electrons, so it would have a neutral or no charge. Okay, so using your slide rule, okay, the first energy level can hold how many? Okay, second energy level can hold how many? Can hold how many? Can hold 8, okay. What you're doing is the s orbital can hold 2, the p orbital can hold 6. So all these numbers that we're putting out here should add together to what? To 16. All right? So following your slide rule, remember it looks something like this. Oops. That goes over here. Okay, so remember these are diagonal lines that go through here. All right, so what's the importance of these big numbers? What are they telling you? Like for instance, we went 1s2, okay, and we went to the top of the next slide and went down. What's that telling you? Okay, that meant we need to go to the second energy level. Okay, so we went to the top of this slide. That's telling us we're not going to a new energy level yet, correct? And that's what the slide rule is telling you. Okay, so as we go forward, here's your 2s2, 2p6. As you go further, that's telling you you need a new energy level. Right there it is. Okay, so how many can the s orbital hold? Okay. And do we keep going down? How many can the p block hold? It can hold 6. Now, which column in the P block is sulfur in? You can't tell by looking up there. You have to look over there or on any periodic table. In the P block only. Okay? So it's in the 4th column. Now, when you look at the 3rd period, the entire period, that's a horizontal row. Now, what column is sulfur in? Okay, now it's the entire period, which would include both of these. Yeah, it's in the 6th column. Okay, so what does that tell you about who has a table out? What is, when you look at either over on this one, the upper right hand corner, or even in on your table, what charge does sulfur form? The very top one in the upper right hand corner, -2. Okay, because remember, okay, how many electrons does this want to gain? It doesn't want to lose all 6 of these. It would rather gain 2. Okay, so that's why you see that -2 in that element box. It wants to gain 2 more electrons so it becomes more stable. All right, so that does it for sulfur. That is the Bohr model. Now, if we do a linear depiction of that, that is the electron configuration. Okay, so you can do a shortcut with that. Does anyone remember what that shortcut is or was? Yeah. Close. Noble gas. We knew what you meant. Okay? So even if you didn't use the shortcut, this would not be very long because you're only dealing with these 5 numbers. Okay? Because even if you add all these together, you get 16. So what noble gas would you have to use? You could use helium, but that's not going to save you much time. You would use neon, so that means you're already up to which number then? You're already up to number 10, because that's the atomic number, 10. Okay, so that means we are already right here. 1s2, 2s2, 2p6. You add all 3 of them together, you get 10. Is this coming back, or is this just, we have no idea what we're talking about? Is anybody lost right now? Noble gas configuration or electron configuration. Okay? So are we all good? Because some of you are falling into the same trap. You believe you understand it, and maybe you do. And the evaluation that gets placed in front of you, maybe the information just leaves. Okay? That's one of the things you're going to have to be able to overcome, whether it's this class or how many of you basketball players on the court, and you get whistled for a foul. There's only 2 people that know for sure whether a foul occurred. The offense and the defensive player. How many of you have ever been called for a foul and said, I didn't even touch him? Okay? So when that happens, again, you have to, if you get a bad call, you have to find a way to overcome that bad call. So, when it comes to these evaluations, whether it's this class or another one, it's something you're going to have to find a way to work through. Whether that's something that we can help you with, I would suggest you do that sooner rather than later. But regardless, remember, we're here before school, after school. Come in, ask questions, try to get you straightened out. It's your choice to do that. Okay, so that means we're already up to here. So we're already up to number 10. What comes after 2p6? What does this tell you? Okay, so now we're up to 12. 10 and 2. So now you go back to your periodic table. In the P block only, sulfur is in which column? The fourth one. So we would put 3P what? So you add these three numbers together, 16. Okay? Now, these get to be a little more difficult the further we go, or the bigger these numbers get. Okay. Renthium, I think that's how you pronounce that. So the very first thing you want to do, you look at where this is at on the periodic table. Okay? This is a D block element. Okay? So inside this nucleus there are 45 protons. Okay? So following our slide rule, okay? First energy level, 2 electrons. Okay? What goes in here now? 2s2. We're up to here, 2p6. Okay? You keep going down the slide. What's that 3 telling you? New energy level, 3s2. Okay? Go to the top of this slide. Are we in a new energy level? No, we're still in the third. And the P block can hold how many? Can hold 6. Okay? As we go down, this slide rule is telling you what with that 4? New energy level. Okay? Go to the top of this slide. Go back down to the third energy level, and it can hold how many? We'll put all 10 of them in there. Okay? So, we go a little further down. All right? 4p what? So, one of the things you can do is stop right there. And if this number equals all of them added together, you know you're done. Okay? Well, we've got 2 and 8 and 18 and 8. Okay? So that gives us so far 10, 28, gives us 36 so far. So we know we have how many more to go? We have 9 more to go. So we can always go back to the slide rule. This says we left off with first, second, third, fourth energy level, the P block. So right there is where we're at, fourth energy level, P block, because remember, the P block can only hold 6, right? Okay, so that's where that number comes from. So what is this telling you? New energy level, so 5s2. And then we go back down to what column is, I think you can pronounce that renthium. What column is that in the D block? Okay? And that has to be right because 7 and 2, you add them two together, you get what? 9. What did we say when we had 36? Subtract from 45, you get what? 9. There's your 9 right there. There's certain predictions that you can make to add these two together, and it shows what column you're in, what period you're in. Now, it is a little confusing going from the P block to the D block, but that's why this slide rule is such a useful tool. Because what fills up first, this fourth or the last of the third? This makes that correction for you. Okay? And also, something else to look at and remember. Okay? What happens when you go past magnesium here? What period is sodium and magnesium in? It's in the third period. But when you go past magnesium, okay, and this is your 3p6, okay, potassium and calcium are in which period? So that's 4s what? 4s2, that's these two elements right here, Okay? But the moment you get to scandium right there, what period is that in? It's not the fourth, it's the third. And that's what this is telling you. It goes from 4s2 back down to 3d10. That's why utilizing that slide rule is such a beneficial tool. Okay? So I can't stress this enough. Some of you, we're putting all of our eggs in one basket and hoping that next week we survive. Some of you may go backwards. Okay? Some of you put yourself in a very unbeneficial position. So that was a personal choice that you had made. All right. Should we continue, or have you had enough? We've got all week to do this, but we've got 2 more to go through. Continue. All right. Okay. Why is it that this looks like it probably is fairly difficult? Why would that be? Because it's such a high atomic number. Oh, my mistake. Should we do the electron configuration for rhenium? Do you want to see that? Yes? No? Okay, remember, this electron configuration is just a linear depiction of what you had just done. Okay, so this was 9 here. Again, these are just the totals of electrons in each energy level. Okay, so if we're going to take a shortcut, okay, what noble gas would we use for rhenium? Krypton. And that is element what's its atomic number? Okay. So once we've got that figured out, okay, another thing you can do is when you find krypton right here, D block elements don't follow these periods very well, but S and P blocks do. So krypton is in which period? The 4th. And what block is krypton in? So the 4th energy level, the P block, is already full. So that says, okay, right here is where we're at. This is full. So as you go further down, what comes after 4p6? 5 what? Okay, we still use the slide rule. Go to the top, and the D block can hold 10, but how many do we put in there? Because what column is rhenium in that 4D block? 7, right? That's what you had said. So 4D7. We can check to see if that's correct. 7 and 2 gives you what? 9 plus 36 gives you 45. So that has to be correct. Okay? So when these elements get a little bigger, yes, it's a little more of a challenge. Okay? But if we follow the slide rule the way it's meant to be used, okay, will probably be more beneficial. So 83. So you tell me, 1s, now what? Okay, so if this is one of the things where you get interrupted, we left off with 1, 2, 3, 4, 5. Okay, so 5p6, right there is where we're at. Keep going. Okay, so then go all the way up to the top. Okay. Okay, so now, before we go even any further, some predictions that you can use to help yourself out. There's bismuth right there. So what period is bismuth in? It's in the 6th period. In which block is it in? It's in the P block. So if it's not a D block element, which it's not, it makes it just a little bit easier, even though this number is so big. Okay? So we left off with 6s2. So what does this tell you? So back down to 5. We're going to put all 10 of them in there? Yes, we are. There's a couple reasons that we know that. Okay? For one, 5d10 is all the way over here to mercury. So once you put that in, how many more columns do we need to go over? Just 3 more. But we want you to put them in there correctly. So we just left off with 5d10. So you just correctly said that what period is bismuth in? The 6th. Which block is it in? So that means that when we get down to here, this is where you're going to stop. Again, that's utilizing that periodic table to your advantage. So 6, 1, 2, 3, 4, 5, 6. Now, what column in the P block is bismuth in? Okay? So another thing that you can do to check your answers, we already know, okay, 1, 2, 3, 4, 1, 2, 3, 4, there's 8, so we're already up to 36, plus 10 more, 46, plus 14, so we're up to 60, okay, 60 plus 18 gives you what? 78. 78 plus 5 gives you 83. There we go. All right. Does it seem like a long time ago since you've done all these? Probably. Probably. All right. Left outside, we doing okay so far? We're nodding our head yes, so that means, okay, left middle, okay, left middle, okay, right outside, okay, middle. We won't leave anybody behind. We know where we're at, right? All right. So this is probably the harder part. This is more difficult than probably an electron configuration because there's so many places that you can make a mistake. So if we're doing a configuration, what shortcut element would we use? Again, it has to be something out of column 8. Xenon, and that's what number? Xenon, 54. So we're already up to 54. So what period is xenon in? So it's in the 5th period, and it's in the P block. So that means we're down to here. 5th period, P block. This is full. What comes after 5p6? Okay. Now what? And then what? Are we done? No. We still have what? Because we know that bismuth is in the 6th period, it's in the P block, and then the 3rd column of the P block, right? Okay. There we go. You add all them together. So 54, 56, 56 plus 14 gives you 70. That gives you 80. That gives you 83. Just what we wanted, 83. All right. So, can we erase this? All righty. Otherwise, you can always go back to the science channel and figure out where we left off. Okay. Europium's probably a little simpler because that number's smaller. Okay. So 63. So you tell me what to put. 1s. Now this one gets to be a little more tricky, but we made that correction. You should have made on your periodic table and this one, okay? Because when we get to here, all right, remember this is where the D block begins, this is where the F block begins. So we're here at 57, so we just left off with 5p6, so we got 1, 2, 3, 4, 5, 6, 7, correct? Okay, so let's go ahead and put them in there. So if we add them together, again, we already know that this is going to be 36. Okay, 36, we'll leave that odd number towards the end. Here we've got 8. Okay, and how many do we have together in here? 18 plus 7 is 25, okay? So 36, 25, and 8, okay? So, something's not right here. Something is not quite correct. So 8. Start over here. Okay, so 2, 8, 18. Okay, 18 and 7 is 25 and 8. Okay, let's try this again. Okay, 33. And then these two is 26 and 2. Okay. 9, 11, 1, 4, 2, 6. Why are we off by 2? We jumped all the way over to there. We forgot about our 6s2. There we go. Okay. Are we good? We're good? We're good? Even in the back? Okay, so if we're doing shrugging our shoulders, shaking our head no, what does that tell you to do? It's your choice, because again, we're in high school, right? Where or are we ready for high school? Yes? No? Because you're 25%, for the most part, 25% done with high school. Okay? That's good, right? Okay. We'll pick up with naming those compounds tomorrow. All right. Catch up to you next time.